Okay, here's a couple of examples that will help out with quiz 6. So I didn't write the problem statement, but it's the same as at the second half of quiz 6. It says, figure out whether these two summations converge or diverge, and if they converge and there's a formula, let us know. Figure out what that formula says it will go to. So the first one. It might be nice to try plugging in a few numbers and seeing what we're getting here, just to see what it looks like. It'll look like if I plug in a 1, I'll have e squared plus 3 divided by e minus 1. Then if I plug in 2, I'll have e to the 4 plus 3 divided by e squared minus 1. And you could get those on your calculator, or you could use an approximate 2.718. Yeah, that's approximately what e is. And you'll notice that those numbers are getting bigger. You have e to the 4 is like 2.7 to the 4th power divided by e squared. E squared is only 2.7 squared. And they're getting larger and larger. But we need to check that. So in order to see whether this converges or diverges, it gives you the idea that perhaps a limit test would be the right thing to do. So you take the limit of that function as n goes to infinity. Or since we know how to take the limit of a sequence by taking it a limit of the function, you could go ahead and plug in the x if you want. So I have e to the 2x plus 3 divided by e to the x minus 1. And if I do plug in infinity to the top and the bottom, I get infinity on top and bottom there. So it's going to be a L'Hopital's rule. I'm getting infinity over infinity here. So that means I can use L'Hopital's rule on it. So I'll take the, I wrote my plus 3 as if it was an exponent, but it wasn't. It was, I need to watch the original problem, plus 3 like that. And so the derivative of the top will be 2 e to the 2x, and the derivative of the bottom is just e to the x. And now I can simplify that, because e to the 2x is the same thing as e to the x quantity squared. Or you can just subtract the exponents. 2x minus x equals x. So we have limit as x goes to infinity of 2 e to the x. Canceling one of the e to the x's or combining the exponents. And as x goes to infinity, 2 e to the x equals infinity. So the limit test gives me infinity, and then that means that the answer to the problem is that it diverges. Will be infinity either way. If the limit test says it goes to infinity, then the summation will go to infinity too. All right, so let's look at this one. Okay, right now we only have 2 ways to determine a convergent or divergent infinite sum. The limit test, which, by the way, only to remind you, tells you that it diverges. The limit test can't tell you that it converges. If the limit test came out to anything but 0, diverges. So infinity is definitely greater than 0. That's the key here, I should mention. Infinity is greater than 0, So we get diverges. If you got 1, still be diverges, or 15, still be diverges. If you get 0, you get, I don't know. You have to work it out. That would happen here too. If I decided to try the limit test on this problem, then it would come out to 0, but it wouldn't tell me for sure. So this problem, though, looks as though I might have a chance of using the geometric series test. So that's because I can rewrite this sequence, or series. First of all, there is a 3 multiplying 2 to the n. That doesn't have an n in that 3, it's a multiplier of the whole thing, so I can pull it out. And then what's left is a 2 to the n over 3 times 2n. Or 3 to the 2n. Sorry, that's 3 to the power 2n. So in order to get this to look like a geometric series, what I'll need to do is one more just algebra item. I need to have just 1 power of n on this one. So, one more time. Let's see. On top there's a power of n, and on the bottom there's a power of n, if I write it like that. So, that big power n goes on the top and on the bottom by rules of exponents. So it's 2 to the n, and then when it goes on the bottom, you're allowed to combine exponents. If there's an exponent inside the parentheses and outside, you can multiply them, 2n. So 2 over 9 is the actual thing that's being taken, the actual base that's being taken to that power n. Two over 3 squared, or 2 over 9, is less than 1. So the geometric series converges. Whenever you have a series which is a fraction, it has to be less than 1, and it's to a power, then it converges. It adds up to an actual finite number. And you can find out what that number is. It would converge to, you take the 2/9 and you put it into our formula. 2/9 divided by 1 minus 2/9. It's easiest to remember the 1 for 1/2, where it's 1/2 divided by 1 minus 1/2. But for 2/9, the same goes in the same way. And I do have to remember this 3 is out front. So it converges to that 3 times 2/9 divided by 1 minus 2/9. I can simplify that, make that bottom fraction 7/9, because it will be 9/9 minus 2/9. So that'll be 3 times the 2/9, CD, and times the bottom will be 7/9, but then when you want to reduce the complex fraction, it'll be 9/7. And then cancel the 9s, and you'll have 6/7. That's the final answer. Do that fraction work on your own too to double check me. But yeah, no, I'll double check it now. I have 2/9, I have 7/9 from 9/9 minus 2/9. So that's times 9/7, cancels. 3 times 2 is 6. Looks good. So that second question, or the last couple of questions on there, may have something like this, where you have to actually figure out what it converges to.